start 5.6 in this section. We're going to talk about inverse relations and functions. Okay, so first of all, what is a function versus a relation? So a relation is any set of ordered pairs. It can be any group of sort of ordered pairs anywhere. A function is a special relation where each x has at most one y. Okay, so right here we can't have, this is not a function because right here this x value has two y values up here. And so this would not be a function. Okay, so in a function, every x has only one y. All right, so what is the inverse relation represented in this table? Okay, so if we take our x and our y here, x is my independent variable and my y depends on what x is. An inverse relation is formed when the roles of the independent and the independent variables are reversed. So x and y just switches. Okay, so my x becomes y and y becomes x. So in this case, I would have my x and my y in my inverse relation, and I would just swap those two. So this one would become 1, negative 2. This would become 4, negative 1, 3, 0. So instead of 0, 3, it would become 3, 0. And then 1, 1, of course, would be kind of stay the same. And this right here would be my inverse relation. Okay, so we kind of reverse the roles. Okay. So notice I have here for x, 1x goes to negative 2 and also goes to 1. So this would not be a function, right? Because I have for one value of x, which is 1, I have two values of y, negative 2 and 1. Okay, so that would be a problem. Okay, so that's why that would not be a function. Okay, so here's this represented here. Here's my relation. Here's my inverse relation. So in here, this is a function because I don't have any values for x that double, right? I have two values for y. This one is not because, again, my one value for x right here, I end up having two values for y. Okay, and then reorder the pairs based on the new independent variables. So I go from negative 2, 1, 1, and 3. Okay, if the inverse relation is a function f is itself a function, then it's called an inverse function. And you write it like this, f of negative 1 of x. Okay, so that would be like an inverse function. Okay, so identify the inverse relation here. And is it a function or not? All right, so first of all, let's just kind of rewrite all these ordered pairs, inversed. Okay, so we're going to write, this will become 9 and negative 1. This will become 7, 0. This will become 5, 1. 2, 3 will become 3, 2. 3, 1 will become 1, 3. And then 4, 1 will become negative 1, 4. And let's sort of reorder them. So for my x's, it'll become negative 1, 4 will be my smallest one. Then I'll move to 1, 3. Then 3, 2. Then I'll have 5, 1. 7, 0, 9, negative 1. And I look through here, it looks like I don't have any x's that repeat that would give me a different value for y. So yes, this is a function. Okay, so it is a function. Okay, didn't write my last two letters there. Okay, so now let's look at how do I write an inverse function algebraically. So just like the values for x and y change to become an inverse, we do the same thing with a function. So the steps are to write a function are this. I'm going to rewrite this as y equals x squared. Okay, so I put y for f of x instead of f of x. Then I'm going to interchange my x and y. Okay, so interchange my x and y. X and y. Okay, so I'm going to write this as y or x equals y squared. So I'm just going to change the x and y position. After I do that, I'm going to solve for y. So I get it all equals, y equals. So solve for y. So I end up getting this y equals something. Okay. So in order to do that here, I want to take the square root of both sides. Okay. So I end up with y equals. And if I take the square root, I'm going to have plus and minus the square root of x. So I'm just going to rewrite this as y equals plus and minus the square root of x. Okay, and that's how you do that. So that's my inverse. So this is my function, y equals x squared. And this is my new inverse relation. It's actually not a function. So we'll look at that in a minute. Okay, so how are these two graphs related? So this is what we're going to talk about. So here's my x squared graph, which is a parabola. That's a function, right? And then my new graph that we just found was the positive, negative square root of x. We have graphed the square root of x before. Remember, it looks like this, where it starts right here and goes up like this. The negative version of that, so that's a positive. So this is the positive square root of x. The negative square root of x is down here, where it gets reflected over the x-axis. And so that's how you get the positive and negative square root of x. It's a sideways parabola. Okay, you can that itself is not a function, because see how we have it doesn't pass the vertical line test. Or to draw a vertical line down through here, 2 values for x. Okay, the other way you can show that it's a function is if you have the line y equals x right here, does it reflect over that? Okay, so there's a reflection over this. Okay, and that's how you find the inverses on that. So the domain of a relation, by the way, becomes the range of its inverse, and so forth. So if you look at my domain and range of my blue parabola right here, my domain is all real numbers, right? My range is all my x's greater than or equal to 0. Okay, let's take a look at our domain and range over here. My domain over here, my domain is going to be all my x is greater than or equal to 0, and my range goes up and down is all real numbers. So notice that my domain of my blue function is my range of my other function, okay? And notice that my range of this function is my domain of this function. So they kind of trade roles, okay? So if you can identify the domain and range of one function, it's easy to identify the domain and range of the other function, of your inverse function, okay? All right, so write an equation to represent the inverse of f. And so again, in this case, we're just going to interchange. Instead of f of x, we're going to write y equals 2x plus 1. We're going to flip-flop x and y, so that's going to become x equals 2y plus 1. And we're just going to solve for y. So subtract 1. X minus 1 equals 2y. And then we're going to go ahead and divide by 2. And so y is going to equal x divided by 2. I'm just going to write 1/2 x. And the negative 1 divided by 2 is minus 1/2. And there's my new equation. Y equals 1/2 x minus 1/2. Okay? So if we come over here, we had our y equals 1/2 x minus 1/2. Whoops, from my x. Get that back here. 1/2 x minus 1/2. So how do we graph that and see what it looks like? How can you use the graph to determine if the inverse of f is a function? So we have our intercept of 1, slope of 1, 2 over 1, 1, 2 over 1 right here. And I'm going to get a line here and graph that. Make sure I have the proper color here. Okay. And then let's graph our green graph here. We have a negative 1/2 as our y-intercept. Negative 1/2 right here. And our slope is 1 over 2. So we're going to go up 1 over 2, up 1 over 2, or down 1 over 2 this way. Okay. And we're going to go ahead and graph that guy. And make sure we have proper color here. And next thing we're going to do is we're going to graph the line y equals x, because we're going to see if that's a reflection here. Okay. Okay. And is there a one-to-one reflection around that line y equals x? There is. So remember back over here. Go back to our graph over here. Okay. It intersected on that graph right there, right? Okay. So that's how you graph the line of reflection with that guy and how you tell it's a function. Okay. So how do you restrict a domain? So consider again this function, this parabola. Under what domain will the inverse be a function? So remember, this is not a function because it had a sideways parabola, so it was not a function. It didn't pass the vertical line test. Okay. So we have a problem here, because if you take these 2 points, 2, 4 and negative 2, 4, if you reverse them, it's going to be 4, negative 2 and 4, 2. So that would mean this value of 4 for x would give you 2 values for y, negative 2 and 2. Okay. And so that would be a problem, right? Then we end up with a sideways parabola. So how do we deal with that? Well, we're going to eliminate our duplicate y values. So we're going to kind of cut off this left-hand side of this graph right here. Okay, so our domain used to be for this parabola here, our domain would be all real numbers, right? But instead of that, we're going to say, no, we're going to make our domain be x is greater than or equal to 0. Okay, so that's the only kind of part of the graph we're going to keep. So now when we do this, we have this graph right here. Then we're going to restrict that domain to just all the values for x is greater than or equal to 0. Okay, so then when I graph its inverse, I'm only going to have this positive square root of x function right here. And then you'll see right here, there's my line y equals x, and we're all happy campers now. Okay, it reflects around that guy. Okay. There's more than one way to restrict the domain of a function. The context of the situation often influences our choice of domain, okay, depending on how we restrict it. All right, so find the inverse of each function by identifying appropriate restriction of the domain, right? So right here, we have our domain. If you can imagine this graph right here, we shift down 9, right? If we just put -9 down here, this is a parabola that shifts down 9 right here. So just kind of imagine that. So what would our domain be for that function right there, for this graph? Our domain would be all real numbers, right? And our range would be all of my values for y is greater than or equal to -9, right? And so we know that we're going to have to kind of cut off this side of my graph, right? We're going to restrict our domain to x is going to have to be greater than or equal to 0. Okay, so then in my inverse function for f of -1 of x, my domain then is going to be what my range is here. X is going to be greater than or equal to -9. So when you switch a domain and range, it's still going to be the proper value. So this was y, this is going to be x, right? Because it's a domain. My range is going to be this guy right here. X is greater than or equal to 0. Okay, so you just have to flip-flop those, and that's what my domain range is going to be for my new function. That will be my domain range for there. So if you can imagine that, it's going to be x is greater than or equal to -9. So we're going to come over here to -9, graph like this, and here's this guy right here. This is going to be like a little reflection. I didn't graph that very well, but it's going to be something like that where there's a reflection on that y and y equals x. Okay. Okay, so I'm sure you're going to have some questions on this, so be sure you bring your questions to class. You have an Excel and Google Classroom, and then I will see you all in class. Thanks a lot. Bye-bye.